Suppose we want to take the derivative of the function capital F of x equals 4x minus x squared as a quantity raised to the 20th power. Previous to this section, our best approach would have been to use binomial theorem to expand this and obtain a polynomial with 21 terms and differentiate term by term. But that is not a very pleasant thing to do by hand. So let's look at how the chain rule can make this a much simpler and quicker problem. I'm aware of at least two main bookkeeping techniques for handling the chain rule. One of them is illustrated in the textbook. I will show that second. So if that makes sense to you, it's reasonably quick, and it's what I recommend if you find an easy time doing that. Some students find that a little bit confusing, a little difficult to keep track of. So for that purpose, I will demonstrate how we can use intermediate variables to help us out here. So first off, since we have just a function expression and not a variable, let's give that a name. We'll call it y. If our function is given to us as a y equals to begin with, then we don't need this step. But we're just giving a label to the expression that we have here. So looking at this, this is more complex than our simple derivative rules so far can handle. If we take kind of a step back, we see that at sort of the top level, the last thing going on here, y is essentially something to the 20th power. Okay. So let's introduce an intermediate variable we'll call u, and we'll let u be the stuff inside, whatever it is we're taking to the 20th power. That is 4x minus x squared. Okay. With that notation, y now is u to the 20th, right? Now, if we look at u and y, u is a rather simple function of x. This is a polynomial. We know how to differentiate that term by term. Y is a simple function of u. We can differentiate that. So if we want to find the derivative, dy by dx, well, we have y as a function of u, so we can compute the derivative dy by du, and multiply that by, we have u as a function of x, so we can take du by dx, and it's going to be that product, right? So let's work these through step by step here. dy by du, well, y is equal to u to the 20th, so dy by du is 20 u to the 19th, using the power rule. And we multiply that by du by dx. Du by dx, the derivative of u with respect to x, will be the derivative of this polynomial here, that is 4 minus 2x, using linearity and the power rule. So we have that dy by dx is equal to 20u to the 19th times 4 minus 2x. But u was a variable we made up. That was not in the original statement, so we need to rewrite that in terms of the given variables. So that is 20 times u, which is 4x minus x squared, to the 19th power, times 4 minus 2x. And there we go. Right? This Leibniz expression of the chain rule is hopefully relatively easy to remember. You can kind of see the chain going on here. This differential du, differentials, we'll talk about them in greater detail later. They're not exactly ordinary real number quantities, but we can do certain kinds of arithmetic and algebra with them. And in this particular situation where we have all these ratios of differentials, we can basically say du over du equals 1, and that would cancel out and give us dy over dx. So that is basically what's going on here. So we have that nice clear connection, and we have that expression. Some students like this because there's a very clear organization of the relationship between the functions, but there is a fair bit of writing. So if you prefer, you can approach this problem more directly. You can simply say that f prime of x is equal to, and the way the chain rule works is it tells us when we have a composition of functions, we can take the derivative of the outermost function with respect to the inner function. The outermost function is this power function with the exponent of 20. So if you have something to the power of 20, the power rule tells you that it is 20 times that thing to the 19th. But we now need to multiply by the derivative of whatever that thing was, because of the chain rule. That thing was more complicated than just x. So we need to take a further derivative there, and we have 20 times 4x minus x squared to the 19th times the derivative of this, giving us 4 minus 2x. And that should be the same result as we had here, 20 times 4x minus x squared to the 19th times 4 minus 2x. Usually much less writing this way. Some students, when they're getting started with the chain rule, have a little bit of difficulty keeping track of the hierarchy of compositions, in which case introducing an intermediate variable as a label could be helpful. But if you're fine with that, if you can easily kind of track through the nested functions you have, you don't need to bring in a u or any of that business. You can just kind of run through the derivatives piece by piece as we go there. So a couple different bookkeeping techniques. Both of those give us results much easier than trying to expand this binomial first and work through it that way.